Welcome back to the repair bench again. It's another Saturday and it's another Williams board. This one is a Sinistar for Andy at Arcade Club in Bury. So I've had this one in the drawer for a little while waiting to be done, and my knowledge wasn't brilliant, and having done 2 or 3 Williams Defender boards not that long ago now, I thought this is time to revisit this and get this thing nailed once and for all. So I've skipped the usual sort of preamble, and we've gone straight for the Fluke 6809 E-Pod. The big guns are straight out because, well, I just don't have that kind of time in my life. It's a non-booting board. This is what you're getting on the screen. You've got a RAM error going on. I haven't got the screen turned around the right way. I can't quite read that anyway, but what we've got is a RAM error. I've got the Williams loom that you've seen in the previous video now set up, and all plugged in, and we've got, if we try to do a run of the game, what we should see is, there we go, 034, which is telling me something about RAM, particularly screen RAM. Now, it's the same kind of memory configuration as the other Williams boards, like the Defender and Joust, the earlier ones. And you've got basically 3 banks of 1-bit RAM. So 16K, 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 48K total there. Ooh, and the whole thing's just decided to sort of die and go off on me for some strange reason. Well, there are many reasons why that sort of thing happens. There we go, we're back. It's probably me just touching the board. Just run that again. What have I done? Run. There we go. That's better. So it was just me tapping the board. It happens from time to time. I've got it sort of balanced. I've got a couple of one screw in each corner just so it doesn't flop around and end up shorting itself out. Anyway, it's not booting, and it's telling me whatever number it is down there. Now, the good news is that knowing... that's a better version of it. Sorry, I kind of get a bit scatty here. RAM error 31. Right, well, it's telling you that because it's the first RAM it can't actually access. Here's what's going on. So we can see some screen clearing roughly going on, which is a very good sign, but we've got some other problems. If I try to read D000, which is where the ROMs start at, I'm getting numbers back, which is correct. Oh, sorry, so that's 9,000. ROM D000. 94th line at D000. What's that mean? Set up. Did I reset the Fluke? I did. I must have reset the Fluke recently. Sorry for being slightly scatty here. Unimany reset. There we go. So we've now got a rug pattern starting to come onto the screen, and we've got... we did have a... Yeah, there we go. 034. Right, let's try and explain it again. So the first few ROMs down here appear at D000, E000, and F000. So, D000. The good news is I can read a ROM. read E000. Yep, and read F. I'm getting all sorts of different answers on there. So I read D001, 06, D002, 00. So I'm not getting a bus conflict there. However, if I try to write something to location 0, say, let's not write FF, let's try 00. I should be able to read back 00. I'm getting read at 00 okay now. I wasn't a moment ago. I was getting some other mixed errors. So what I'm trying to do is do a RAM short at 0 to be FFF. And it starts off. Now, it wasn't doing this a moment ago. It was giving me a very different kind of scenario. So, do I need to set something up in order for it to write to RAM? At the moment, the screen's blank. And that's because, I think it's because it's been through and it's tried to clear all the screen out. So, well, you know what I'm going to do? I'm going to leave it to do that. What I was actually seeing was RAM address error on the Fluke. So I was getting sort of I'm doing what's known as a RAM short test at the moment. Not short as in bus short, as in not a particularly long version of the test. It takes forever because it's quite a moving pattern it will spit through. You won't see anything go through the screen at the moment because the screen's blank. But what I was getting there was error writing to address B 0000. And I'm not getting that now. So I'm going to let the RAM test complete and see where it falls over. It's going to have to fall over somewhere because otherwise the board should boot. I'll do the ROM checks as well and see where we get to. One of the things I did find wrong immediately on this board was this 245 buffer chip was dead here, and that wasn't letting it go any further than just a static screen. So we'll come back in a moment. Hopefully that'll either tell me it can fail or pass, and we hopefully should get this game booting up again very shortly. Now then, we've made a little bit of progress in this, so I think I know where the problem is. So here is the screen. I've got a test running at the moment, which I'm going to stop. Okay, and it said okay. This region here is 0 to FFF, 1000 to 1 FFF, 2000 starts, and then because I've got different divides going on, 3000, 4000, 5000, 6000, 7000, 8000. Okay, here's what I think's going on. I think that because normally the memory addressing, and I checked the manual, everything should just go literally from there all the way to the back end of the screen there. So 0 down there, 7FFF, which is just below 8000 there. Okay, we're in hexadecimal, by the way, for those of you going, what the fuck hell's F? So it's not 7 fuck, it's 7FFF, as in 32767 location in decimal. Here's what happens, watch this. So, some magic here. So I'm going to write to 3000 to 3FFF. So 3, 0, 0, 0 to 3FFF, like so, and watch the screen. So what you'll start to see is some yellow bars appearing. It should be about here. Yep, you can see it changing, and it's shortening this block here, and then it'll start to fill that with multicolour pattern as well. There we go. Now then, so I'm not gonna wait for the entire Fluke test to complete and verify all its everythings and all the rest of it. What I'm going to do is, as soon as it's finished filling that block and doesn't look like it's changing anymore, I'm going to stop it. There we go, and it's finished filling that block. Okay, so I'm going to stop that now. And then what I'm going to do is I'm going to try and fill this region here, which should be 1000 to 1 FFF. So 1000 to 1 FFF, like so. Watch. Ta-da! That tells me something's stuck. So this isn't necessarily a RAM a RAM chip issue down here. This is a RAM access issue. And the reason the Fluke isn't telling me that there's a problem is because it's only checksumming the areas, each byte as it writes it. Now, because the memory model is allowing it to write to somewhere and then read that same byte back out of RAM, well, we have an A equals B. So if it writes a moving pattern, so 1 1 2 2 3 3 4 4, and then it reads it back every time. This is why it's so slow, by the way. If it reads it back each time, 1 1 2 2 3 3 4 4, and it gets the same value back, it allows it to continue because it can write it and then it can read it. However, what it doesn't know about is memory organization. Now, here's the thing. When I do run UUT, unit under test, and press return, it will see, note it can't write to those blocks there. And then you get a RAM error there. And the reason it's giving you that RAM error, and it's not showing anything on the screen, I don't quite know why, and it's trying its dangest to fill those things and try again and all the rest of it. What this is doing is it's writing a specific pattern to the screen, and then it's trying to read it all back and get a checksum, and there you go, RAM error 34. But there's not actually a RAM error at 34. It's the way it's trying to access it. So we'll look at, now because we know that this is 1000 to 1 FFF, this little strip here, and again it's having another go. Now it's trying to execute the game at this point, because you can see some of the Sinistar stuff starts up at that section, but it's not getting there, is it? Alright, so what we'll do is we'll have a look at the memory model. I know from, now it's sort of got something in there at this point, and I'm not sure exactly how it manages to do that because the memory controller won't actually let it. And there you go, and it's trying again. So it'll just keep resetting and resetting and resetting. we've got a stuck bit somewhere on something. So this should be reasonably simple to sort out now. Obviously it's blanked the screen out. 1000 in hex is, let's have a look over here on our binary calculator. I was messing around there. So if I type in 1000 like so and go convert, I get 0001. Right, so that's A0, 3, 4, 5, 6, 7, 8, 9, 10, 11, A12. So if I look at what's going on between A12 and A15, because as you move, all these are the 16K, so 0 to 16383 of each RAM location here. So what we're looking for is A12 to A15 on the memory addressing. Let's have a look where they go on the thing. Now, have I got the circuit diagram there still? Right, I was messing through into the RAM locations. There's the CPU at 1E. So what we do is I'll just see if I can just nip in here. A12, A13, A14, A15. Where do they go? Well, they all go to something called an 8297. Let's have a look. So they go to this thing here, an 8297 at 2G. Well, I'm going to have to look carefully at what that is. But that, I would imagine, is going to be my problem. I can set very specific things. Hopefully, what I'll do is I'll have a use of the scope and I'll force read or force write some locations through here and see what comes out on the other side. But there you go, I've got my A13, A12, A13, A14, A15 at that side. If I can make those make sense, then I know that chip there is fine. That's probably a custom chip or something. Where's 2G? 2G is going to be, it's this one, it's going to be that one there. I don't know what that is. I'll have to look up what exactly that is. If I can get the correct sense out of the CPU down to here and get the correct signals on the other side of the CPU, I don't know quite know why they're using, what the heck are they doing with that? It's 8297. Doesn't quite make any sense as to what that is. It'll be something to do with the read-write cycle, don't know. I'm not going to start hazarding guesses. There are, by the look of it, pull-up resistors to make it that those lines will be stuck high and then driven low when they need to be driven low for 0. Let's make sure that they're all going in correctly and coming out correctly. I'll also take a photo close-up of that and see exactly what markings are on the board, because there's a possibility that it has a replacement chip that we can stick in there if that one is the problem. With something like a 1 and 15 as an E2, E4 and a ground at 8. I'm not sure what the heck that chip is, but we'll find out shortly. Its output, the output of that chip is held high and goes over to something on the AYMA. I don't know quite what that is. Looks like a prom of some description, that. Not sure until I see. Anyway, what could be happening over here is, see how we get onto this bus here, and we've got A9 and A8 there. Well, if I look down here and find A11, A blah 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 blah, and go on the address bus, it could purely be that one of the other chips that's hanging off the back end of that is the problem. So at least we know roughly where to start now with our problem. Alright, let's move on. Well, we've made some progress, I think, and I hope. Now, it's clearing the screen properly this time. So I looked around all the memory circuit and everything, and I thought I'd tracked it down to these multiplexers here, these 4, and not to be. So the only thing that was kind of sat in between those, the RAM, and the CPU, was this decoder chip here. Now, I took it out and I've cleaned the legs, and I've given the socket a quick squirt as well, with some compressed air and blown that out. And now it seems to be correctly colouring the screen. The colour map setting hasn't been correctly set just at the moment. It's from initial boot is this. I don't think the palette, whatever gets selected there, gets set until you boot the game. There's probably something that allows that to be set correctly. But at this point, I'm going to go for broke and try and run a UUT. So, waiting, hopefully all systems go. Yeah, except for some corruption up there for some reason, which we don't know about. And some crap across there. Sinistar, Sinistar, Sinistar. So, that's all part of normal boot. Now I don't know whether it's supposed to make a sound on this end or not when it first kicks up. But the game is now running. I'll investigate the sound side. I'm going to have a break, I think. I'm going to investigate the sound, but the game is running again. So I'll report back shortly. I'm not particularly happy about this corruption here and this bit going on here, and down on the thing here we seem to have like half a letter. So I'm going to have to look in the manual, but one thing I did just find is if I go into the if I use my little box here to go through the tests, so I'm skipping the RAM test because that's coming back perfectly fine now. The game won't boot unless the RAM's fine anyway. In a moment this screen's going to tell me I've got a CMOS RAM error. There we go. So I've got that to deal with as well. Now I'm hoping that that's just the chip. If it is, perfect, no problem, just change the chip. I just hope it's not a huge deal again, but it's still a 5101 chip to sort out. Or it could be the fact that we've got really crap voltage going to it. I'll meter this battery here and see what's going on there. In fact, yep, well, the battery's in its spot, nice and secure. We'll see what's going on. Okay, but that's another problem to fix with it. Well, after a little bit of investigation, I decided that all the signals around the CMOS RAM chip were all perfectly okay, and decided to socket it in case we do need to change it. So I took it out and cleared everything, rebooted the game, and it came up, obviously, factory defaults reset. Now the interesting thing here is, when it just cycles back round the test mode, come on, yay! Is it going to do it? Tell you what, we'll reset the game. That's the fastest way to do that. So, all the voltages are correct. The CMOS battery checks out okay. Your all systems go, and now the corruption's gone because I've reset the scores. In the test mode, it is still telling me that I have a CMOS RAM error. So I think the safest thing for me to do, and tell Andy to do, is order yourself a chip. I don't carry these on stock, these. What are they? A TC6514. I'm going to look up to see if I can actually get some of them, but I want to give the board back, and at the end of the day, it's a part that can be got off eBay if there are any. I looked up, and the pinouts of the 6514 are actually identical to a common 2114 chip, which I have over here. Unfortunately, they don't work. It causes a continuous reset. I suspect that the access time is not quick enough, and the rest of the spec of the board needs to be up to it. So anyway, I'm going to leave that to soak test for a little bit. As you can probably hear in the background, it's cold in here for a Saturday, so I've got the old heater on over there. Now somebody asked me what all the white sheets are on the cabs. These are job sheets that need doing with them. There are various things that we note when we're out at a huge show, like Manchester, which was the last time absolutely everything was out, and so we put these on and we write down what's wrong with the cab and snag them and everything, because we've got a few months before absolutely everything's going to be back out again, you know, at the start of the season next year. Anyway, so back to the repair bench side of it. There we go. We have a Sinistar board working, which you will no doubt see at Arcade Club in the next couple of weeks when I meet up and give it back to somebody. Alright, hope you've enjoyed this video, hope it's been of some use to you. If you're any fan of doing board repairs and want to learn more, do obviously go back through our archive. If you've stumbled across this as a search and you want to keep in touch with what we do, then please hit the old subscribe button, give us a like, you know, all that sort of thing. Mash the like button, and you know, give us some feedback below if we're talking a lot of codswallop, tell us, and if we're doing some good. Now, one thing I would like to say is to the person that keeps downvoting all the repair videos at the moment, I know who you are. I know exactly who you are. You're downvoting because you're waiting for your board to be repaired. I wish you'd stop it. It's very petty. So, you know, I'm just going to, every time you downvote the video, I'm going to slow down doing your board repair. It's as simple as that now. So, because there's no need. These are all filmed out of sequence. There's no times and dates specifically on them. You just got to kind of go with the flow that, you know, some of these board repairs happen or happened over a period of time, and I can't stare at one particular board for months and months and months and get nowhere. I've got to keep going, and this big old room here has to be paid for. So, and I appreciate that you have a deal on the go and everything, but like I say, I know who you are. I won't name your name on here, but stop trolling me. Otherwise you'd just do it wait until next Christmas for your board. And if that means you don't vote absolutely every time, I'll publish your name. Alright, anyway, enough said, rant over. We have a... so, anyway, that's it. That's it for this board. I'm going to start on some other ones very shortly. It's time to refresh that cup of coffee as well. Till the next board, till the next video, stay tuned. Bye.